What's up, YouTube? This is Mr. King coming at you live. So today we're going to be going over common misconceptions in high school science. And I'm going to take you through the most common misconceptions I saw while teaching biology, chemistry, and physics. Misconception number one. This one came from biology. So in biology, we talked a lot about climate change. And the main one that I saw that was difficult to debunk was that the main way to solve climate change is to consume less, like using less energy, eating less meat, etc. So a lot of students I found felt like if we all pitch in and do our part, then we don't need to worry about climate change. And this is really tricky because the fossil fuel industry has spent billions convincing regular citizens to focus on personal responsibility instead of systemic change. And this belief is pervasive. A lot of people think this, and it's because there's been a big industry to push off responsibility onto the individual person. But in reality, climate change is tricky because students need to realize that yes, you should consume less. You should turn off the lights when you're done using them. You should eat less meat, but also you should advocate for systemic change because to tackle climate change, it is very tricky and you need to have a lot of systems in place that need to change so there can be less emissions of carbon. So consuming less, yes, but also causing for more green power sources or less gas emissions using like cars or in factories, things like that. More renewable energy and green energy like nuclear. Okay, so common strategies to debunk this is help students understand why the fossil fuel industry wants us to focus on our carbon footprint. So I talk about like why is it British Petroleum that really emphasizes personal responsibility? Why isn't it like the EPA? But why is it like gas companies that really focus on the green actions on the individual level? And then we also talk about other ways to reduce climate change at a systemic level, just to help them realize there's more that you can do besides turn off your lights. Number two, this one comes from physics. Heavier objects will fall faster. So, for example, a lot of my students thought you drop a basketball and a tennis ball, the basketball will hit the ground first. Or you have two cars going down a ramp, the heavier one will go down faster. This comes from a preconceived notion where, in our experience, heavier things have more force, so they'll fall faster too. Because if you drop a bowling ball on a basketball, that bowling ball is going to have a lot more force coming down, so you assume it'll be faster. But to debunk this, we do a couple of things. One is a live demo, and the other one is using math. So in physics, I try and teach the students. In reality, yes, a heavier ball will have more force, but the more force will be canceled out by the more mass, resulting in the same acceleration for both balls. And this can be summarized by gravity affects all objects the same. So good strategies for debunking this one, hands-on demonstrations. This one's very simple. You, the teacher, or the students themselves could be doing a slow-mo video and see whether dropping a basketball and tennis ball, which one will hit the ground first. And then they should be able to see, same shape, it should be able to hit the ground at the same time. Also, math is a great way to reinforce concepts in physics, such as, in this case, like having acceleration equal force divided by mass. So the greater the force and the heavier the mass, those two will cancel out. Last one, this one comes from chemistry. Fridges and ice cubes use cold energy. So they release or absorb cold. And this is a tricky one too. This one is a vernacular misconception because instead of things getting cold, in reality, they're just really losing heat. So there's really no such thing as like cold energy. It's really just losing heat. So you try and convince your students to use the terms heat when describing things getting cold. So if you put ice cubes in a glass of water, the ice cubes aren't releasing heat, or the ice cubes aren't releasing cold or heat. They're technically absorbing the heat. They're taking the heat away from the ice cube, from the water. And this can be tricky because in the media, many characters are shown releasing cold with like ice powers. So they release the cold, they make things cold, like Frozone or Iceman. And this can be misleading because in reality, when something's getting cold, it's really just taking the heat away from something or absorbing heat. And one of the best ways to debunk this is by telling students how it actually works. So in reality, heat is how fast the atoms inside objects are moving. So if you have a slower atom, that means it's colder compared to a hotter atom. So good strategies are a very good visual or a real world example. For example, fridges. They keep our food cold, not by releasing cold, but by absorbing the heat. And what I try and tell students is, have you ever put your hand behind a fridge? You may notice that it's really hot, and that's because the heat from the fridge gets pumped outside. And in this picture, you can see a lot of the heat gets released to the back of the fridge. Yeah, so that's just showing that's how it keeps cold. It takes the heat away. And another good strategy is to spend more time on the facts than addressing the misconception. So instead of spending a lot of time talking about the misconception, that can do more harm than good because it can reinforce the misconception. Rather, teachers should focus on the facts. For example, ice cubes absorb heat. Don't talk about how they don't release cold, just emphasize heat flow and have students talk about heat to really reinforce that concept that instead of things getting cold, if something makes something cold, it's taking the heat away. It's absorbing the heat. And we talked about this a lot in endothermic and exothermic reactions. To summarize, to debunk a misconception, students need to understand what really happens and why. And the best way to do so is with hands-on visuals and hands-on experiences. And this is a really good skill because teaching students to debunk myths demonstrates that they can apply their knowledge to real-world contexts. For example, when I taught physics, a lot of students, once they saw the demo, they're like, okay, things fall in free fall at the same rate, but they still didn't realize that a heavier truck won't fall down a ramp faster than a lighter car. As long as they're the same shape, the mass won't make a difference because gravity makes it all fall the same. So students really understand why the misconception is wrong, but really focus on the facts of what actually happens. That's the best way to debunk a misconception. Thank you so much for watching, and here are my references. Thank you so much.